everyone in Oli board. And in this session, we are going to cover our very important chapter, work, power, and energy. Clear? And so this is easy chapter also, and not so much lengthy chapter. It's a small and sweet chapter, and concepts are very easy to understand from work, energy, and power. Okay, so I will explain all the concepts in very easy manner, and you will get to know all the things. Okay, and we will discuss some important points also, whatever it is important for your upcoming examination. Clear? So take your pen and paper and make your notes. Okay, and let's start our class. Work, power, and energy. Work, power, and energy. This is today's session. What is work? Here is the definition is given. When a force is applied on a body and a displacement is carried out in any direction except in a direction perpendicular to the direction of force, means in which condition you will get some amount of work done. In all the conditions, in all you will get some amount of work except the direction in which force and in which applied force and displacement you are getting. Let's say you are applying the force in downward direction. Clear? Downwards direction, this is a direction of force and this is the direction of displacement. Okay, force and displacement, what is the angle here? Angle is 90 degree. Clear? So in this condition only you will get your work done 0. In all the other condition except that the angle between force and displacement is 90 degree, you will get some amount of work done always. Either it can be negative or it can be positive, but definitely you will get some amount of work done. Clear? So that is the definition. When a force is applied on a body and a displacement is carried out in any direction except in a direction perpendicular to the direction of force, an amount of work is done by the force. It is understood? Clear? Now what is the formula for work? Work is given as force into displacement. Force into displacement. Like this is not distance traveled is not the correct word. Force into displacement. Okay, the shortest distance you should multiply with the force. So F dot D. This is what? This is work done. Work is a scalar quantity. Very, very important. Why it is a scalar quantity? Because we know that the dot product of two scalar quantities is always a scalar quantity. Clear? Force is a vector quantity because it has direction as well as magnitude. Displacement has direction as well as magnitude, so it is also a vector quantity. And the dot product of two vector quantities is always a scalar quantity. Is always a scalar quantity. Clear? So work is equals to F dot D is equals to F D cos theta. Whenever you remove this dot, na, always we put cos theta here. This is the dot product concept basically. So work is nothing but FD cos theta it is. So you should remember the definition of work from this formula, that work is equals to FD cos theta, and this explains that when the angle between force and displacement, basically this theta is what? This theta is nothing but it a angle between force and displacement. This theta is the angle between the applied force and the displacement carried out. Clear? So when the angle this theta becomes what? This theta becomes 90 degree. So obviously we know that cos of 90 is equals to 0. So by putting theta equals to 90 degree, you will get 0 work done. You will get 0 work done. Clear? And the very famous example is coolie carrying a weight. Coolie carrying a weight is the example of 0 work done, because coolie carry weight on his head, so that weight applied force in the downward direction and coolie moves in the forward direction. So displacement is in this direction. Okay, let's say horizontal and right side in the direction, and force is downward. So what is the angle between force and displacement? It is 90 degree. Clear? In the case of coolie, when coolie carries a weight in railway stations, so coolie always done 0 work, always do 0 work. Clear? So please remember this, and I hope now this is clear, what is work done and what is the formula for that. It is understood. Now here you can see this person is pulling this box basically. Okay, this box has some mass. Okay, and this is the direction of applied force, this is the string, and this is the direction of applied force, and box is moving or sliding over the surface in this direction. So what is the displacement direction? This is the horizontal in the right side, this is the direction of displacement. So theta is the angle between them, and we know that work is equals to FD cos theta. This formula explains all the application of work. Clear? And what is the unit of work? Unit of work is joule. Unit of work is joule. 1 joule is equals to Newton into 1 meter. 1 Newton into 1 meter. Clear? 1 Newton into 1 meter, which means F dot F into D, basically you can say normal product. F is force, SI unit is Newton, and D is what? Displacement. Displacement is nothing but it's a distance. So displacement, what is the SI unit of displacement? It is meter. Clear? So Newton into meter is the another unit of work, and the SI unit is joule. Clear? Very, very easy. Work done by a force may be zero, positive or negative depending upon the direction of applied force and displacement. Okay, so this is very, very important, that work can be zero or negative or positive. Okay, all the three possibilities are possible in the case of work. Clear? What is the condition for zero work done? Coolie is carrying some load, as I explained that whenever coolie carries some load on his head, let's say this is a coolie, okay, and traveling or walking on the railway platform, and he is carrying some weight. Okay, he is carrying some weight here. So see, this is coolie, and this has some mass. This attache, or you can say suitcase, has some mass. So this suitcase will exert some pressure on the coolie in the downward direction with the force of mg, which is the force of gravity. Clear? And now coolie is moving in this direction, in the forward direction. So what is the displacement of coolie? This is the displacement. And what is the direction of force suffered by the coolie? This is the direction of force, that is perpendicular direction. So what is the angle between force and displacement? 90 degrees. So work done you will get will be zero. So coolie carrying some load is the example of zero amount of work done. Coolie carries some load is the example of zero work done. It is understood now? Very nice. What is the another example for positive work done? When a body falls freely under the action of gravity, work done by gravity on the body is positive. Similarly, when a body is pushed or pulled by a force, when a body is pushed or pulled by a force, it is called as positive work done. Clear? Now here you can see, let's say this is a ball. Okay, this is a ball, and when you drop the ball comes in this direction. That is, this is your earth, and you dropped the ball at this height. You dropped the ball at this height. So this ball will come on the ground. Okay, will fall towards the ground. Clear? And so this ball has, let's say, some mass m. So what is the force? What is the force of gravity the earth is applying on this ball? That is mg. That is mg. This is the force, and ball is also moving in this direction. The direction of movement of the ball is also downwards, and force that ball is experiencing at this particular time, it is also in the downward direction. Clear? So what is the direction of displacement? It is also in the downward direction. What is the direction of force? It is also in the downward direction. So work done is what? Work done is what? Work done is F dot D, that is FD cos theta. Clear? And here force is also positive and displacement is also positive. Both are in the same direction. Same direction. Okay. And see, if both are in same direction, so what is the angle between force and displacement? Zero. What is the angle between force and displacement? It is zero. Force is also in this direction, displacement is also in this direction. So theta is what? Zero. And we know that cos theta, zero, cos zero is always one. That is, you will get positive work done plus of FD, because applied force is also positive, displacement is also in meters, and it is a length or it is a distance, so it will remain always positive. Clear? So you will get positive amount of work done in the case of freely fall of the body under the action of gravity. Clear? Similarly, when a body is pushed or pulled by a force, let's say this is a man and he is applying some force on this table. So this is the direction of force applied by this man, and displacement of the or movement of this table is also in this direction. So again, force and displacement both are in same direction. So theta is zero, which means work done you will get as positive FD. Similarly, when this man is applying force or pulling, this is a condition of pulling. Okay, and this is the condition of pushing. In both pushing and pulling, the work done you will get, it will be positive. Clear? So now he is pulling the table. So he is applying the force in the on the table in this direction. Okay, pulling towards himself. He is pulling the table towards himself. So what is the direction of force? Towards the man. And what is the direction of movement of the table? It is also towards the man. So what is the displacement direction? it is also towards the man. So force and displacement both are again in the same direction, which means theta, the angle between force and displacement, it is 0 degree. It is 0 degree. So work done, you will get, again you will get positive amount of work done. And what is the last condition for negative work done? What is the condition for the negative work done? That the force of friction acts off against the motion, hence the work done by frictional force is negative. Hence the work done by the frictional force is negative. Okay, the force of friction acts off against the motion. See, you have to remember one word, that force of friction always do negative work done. Always do negative work done. How you can explain this? Let's say just a simple example of, this is a surface. Okay, this is a road. Okay, let's say, and this is what, and this is some truck or whatever you can say, some vehicle or okay, and so if this vehicle is moving on the road, okay, so what will happen here? What is the displacement direction of this vehicle? This is the displacement direction of the vehicle, clear? But in the road is a rough surface, this is a rough surface, okay, rough surface. So this road will offer some friction to this vehicle, clear? So friction works always against the motion. Okay, if this bus or whatever it is moving in this direction, let's say right side direction, so what is the direction of displacement? This right side is the direction of displacement. So the frictional force will always work against the motion. Okay, so this is the direction of force. So this is the direction of frictional force. This is the direction of frictional force. So what is the work done by this frictional force? Work done is equals to FD cos theta. And here you can see the displacement and force both are at 180 degree. The angle between the force and displacement is 180 degree, which means theta is 180 degree. Okay, force is in another direction, and in just opposite to that direction displacement you are getting, clear? So theta is 180 degree, which means cos 180 is what? Cos 180 is -1, clear? Cos 180 -1, that is you will get minus FD, that you will get minus of FD, which means negative sign, which means negative work, which means negative work, clear? So these are all the three examples for the negative work done. Frictional force always do negative work, clear? And you got the example of positive work done also and zero work done also, clear? So this is for work. Now let's come to the power. Okay, we have done our work part, okay, and we have discussed all the information related to work already, and now it's time for power. Okay, what is power? The rate of doing work is called power. What is power? The rate of doing work. Very, very important, because there is a very minute difference between power and energy. Energy is what? The ability of a body to do work. The ability of a body to do work is called energy, and the rate of doing work is called power, which means how fast you can do any work. How fast you can do any work, that is called power, clear? That is the rate of doing work. And whenever the term rate comes, which means we divide that quantity, whatever we are talking about like work, we divide that quantity by time. So power, what is the definition of power, or what is the formula for power? It is work upon time, the rate of doing work, the rate of doing work, clear? Means how fast can you do any work. Let's say there are two persons. First person, he can do some 100 work, let's say quantity of work is 100, and he can do this work in 5 hours. Okay, so what is the power of this man? Basically 100 upon 5, that is 20 watt. 20 watt is the power of this man, clear? Let's say there is a second man. Okay, second man, and he also wants to do 100 amount of work done, but in this condition he took how much time? He took let's say 20 hours to do the same work of 100 units, clear? So what is the power of second man? What is the power of second man? That is 5 watt, clear? So his power is less here, and the power is more here, clear? So that is the definition of power, that the rate of doing work, how fast you can do any work, that is called as your power, clear? Next, when a body takes less time to do a certain work, its power is said to be more, and vice versa, just as I said in this example. What is the unit of power? Unit is watt. And joule per second you can say, because work, unit of work is joule, and unit of t, that is it is time. So what is the unit of power? Power is joule per unit time, joule per unit time, clear? And SI unit is watt. 1 kilowatt is equals to how much? 1 kilowatt is equals to 1000 watt, and 1 horsepower, please remember this, very easy but very frequently asked question in the examination. What is the value of 1 horsepower? 1 horsepower, it is always equals to 746 watt. 1 horsepower, it is equals to 746 watt, clear? Now come to energy. As I said, energy is what? The ability of a body to do work is called as energy. What is the energy? The ability of a body means that you can say, in the simple words, I can say up to what time you can do some work. Okay, up to what time you can do some work. Let's say there is some very healthy man. There is a healthy man. Okay, there is a healthy man, and so he can perform some work, up to 20 hours, and after that he will get tired, and then he will take rest, clear? Now there is a sick man, and that man, because he is a sick, he can do work, he can do that same work up to 5 hours only. After that he will also be get tired and he will take rest then, clear? So whose energy is more, or whose energy is greater? The energy of healthy man, because its ability to do any work or to perform any work is very high in comparison to that sick man, clear? So basically, what is the definition of energy? The ability of a body to do work, how much that body is capable to do some work, this is called as energy, clear? When a body can do more work, it is said to have more energy, like the healthy man, and vice versa, like the sick man, clear? Now energy refers to the total amount of work a body can do, and power determines the rate of doing work. I have written the difference between power and energy. Energy refers to what? Total amount of work body can do. And what is power? Determines the rate of doing work, which means how fast can you do some work, that is power, clear? So there is a very big difference between energy and power, please note it down. Now what is kinetic energy? So kinetic energy, it is nothing but it is the energy possessed by a body by virtue of its motion. Means when some body, whatever it is, let's say this man is running, he is running very fast, clear? So this body is in motion, so whenever somebody or whatever it is, if that body is in motion, that body is always possess some energy, and that energy is called as kinetic energy. If this he is a man, let's say, okay, and this man is of mass, let's say the mass of this man is 80 kilogram. Okay, the mass of this man is 80 kilogram, and he is moving with 30 meter per second velocity. Okay, he is running very fast. Okay, like 30 meter per second. So this moving man will possess some amount of energy, okay, in his body, and that energy is called as kinetic energy. And what is the formula of kinetic energy? It is half of mv square, where m is what? Mass of this man, and v is what? Velocity of this man, velocity of the object, of the body or object, okay, or this is mass of the body. And this is the formula for kinetic energy, that is half m v square, that is half m v square. Is it understood? Clear? And in the similar manner, there is potential energy. The energy possessed by a body by virtue of its position is known as potential energy. Kinetic energy is what? The energy that any kind of body contains when that body is moving, or when that body is in motion, let's say. And potential energy is different kind of energy. It is basically the energy possessed by the body by virtue of its position with respect to some base. Okay, in potential energy, always we measure the potential energy by taking some frame of reference, or by taking some base. Okay, just like always we calculate the potential energy by taking earth as our base. Okay, earth surface as our base, and we always consider that on the surface of the earth, potential energy is zero. We always consider, okay, to calculate the potential energy of any object, we always consider that the potential energy on the surface of the earth is always zero, clear? So what is the formula for potential energy? Potential energy's formula is mgh, where m is the mass of any object, m is mass of any object, g is acceleration due to gravity, which is fixed on the earth's surface, that is 9.8 meter per second square, and h is height of that object from the earth's surface, from the earth's surface. Let's say this is a small hill, okay, this is a small hill, and this is a car, okay. So, and this is your earth surface, this is your earth surface. So let's say this car is at height h above from the earth surface, this car is at height h above from the earth surface. So this car has some mass, this car has some mass, and acceleration due to gravity is constant. So what is the potential energy possessed by this body? It will be mgh. The potential energy possessed by this body will be what? mg and h. Let's say now this body is at this position, okay. Now car came to this position, okay. So again mass is m and acceleration due to gravity is constant, but now the height of this car is changed and it is h1 now. So what is the potential energy here? Potential energy will be mgh1, mgh1, and this potential energy 1 will be less, this potential energy will be less than the original potential energy when the car was at height h, which means it depends upon height. Potential energy depends upon what? Depends upon the height of the, upon the height of the object from the ground, of the object from the ground. Clear? Very, very important. Potential energy. Now potential energy is mass into acceleration due to gravity into height. At the surface of the earth, height is 0. Now from this formula you can relate, at the surface of the earth height is 0, so potential energy will also be equal to 0. Potential energy will also be equal to 0. Clear? So always we consider the earth's surface as the base, and because we need some frame of reference to calculate the potential energy of any body on the, on this earth or whatever the place it can be, we always take potential energy on the surface of the earth 0, and with respect to this we calculate the potential energy of any body or object. Clear? So potential energy, it is the energy possessed by the body when any body is in rest condition, okay, or when it is at some height above the earth's surface. And kinetic energy is the kind of energy which is possessed by the body when that body is moving with some velocity, when that body is moving with some velocity. And now we will discuss law of conservation of energy. What is law of conservation of energy? So there is a very famous law that energy can neither be created nor be destroyed. It can be transformed from one form to another form. Very, very important, very, very important, and everyone knows that. What is the conservation of energy? That energy can neither be created nor be destroyed. It can be transferred from one form to another form. Means you can't destroy energy. Okay, if you, let's say, trying to destroy some kind of energy, if you are trying to destroy some kind of energy na, then actually you are not destroying that energy, you are changing that energy. Okay, if you know or you don't know, you are changing that energy into some another form of energy, you are changing that energy into, okay. So energy will be conserved, always energy will be conserved. Clear? We will see a small example here. This is a girl and she is holding a ball in her hand, and let's say this ball is at rest in the initial condition, and this is our earth surface, this is our earth surface. Let's say this ball is at height h, this ball is at height h above from the earth surface, and this ball is at rest. Girl is holding, this girl is holding this ball. So what is the potential energy of this ball? It is mgh. M is the mass of this ball, m is the mass of this ball, and this girl is holding the ball at present, so potential energy is mgh. Now this girl just dropped the ball, okay, she dropped the ball, and the ball is moving in downward direction now under the action of gravity. This ball is moving in downward direction under the action of gravity. So now height is reducing with the time, height is reducing, but what, but velocity of the ball is increasing. But velocity, as the time goes on, this the velocity of this ball, it will increase, it will increase with time, okay. And so height is reducing, so what is the value of potential energy? mgh. And if this height is reducing, which means value of potential energy is reducing, but at the same time the velocity of the ball is increasing continuously. So we know that what is kinetic energy? Kinetic energy is half mv square. M is the mass of the object or mass of the ball. So mass is constant here. Mass of the ball, mass of that ball, it is constant, but its velocity is continuously increasing. So basically kinetic energy is increasing because kinetic energy and velocity are directly proportional here. So this example basically explains the law of conservation of energy, that we are changing this potential energy into kinetic energy. Okay, basically energy is not destroyed here, just it has changed from potential energy to kinetic energy in this condition. Okay, as the potential energy will decrease, the kinetic energy will automatically increase. Clear? In the similar manner, all the forms of energy and or all the kinds of energy, always you can change only one form of energy into another form, but you can't destroy the energy. Clear? And that explains the law of conservation of energy. So this was very small chapter. Okay, and